Hello everyone, this is Mo and it's our first episode of Design for 3D Printing series, and in this series basically we're gonna tackle product design in a different way. Basically we all have at least a friend who has a 3D printer, and basically what we're gonna do in these episodes, we're gonna take a certain idea that just popped up in my mind across, I would say, like living in my house, I saw a need for a certain product. And since I'm going to do a 3D printing for it, so basically I need to design it. And in order to design it, I need to apply all of the product design principles on that particular object. So basically in this series, it will be more of this is the idea, guys, and this is the modeling of it, or the 3D modeling of it. There will be a lot of fast forwarding in the CAD modeling session, and there will be basically I will be silent during this particular section. I will be actually working live on the modeling part, but I will fast forward that part, and later on you will see the final result, and I will try to narrate as much as possible in the specific sections in that session. So basically our first object today is basically designed for this small one. I'm pretty sure so much of us have this particular cup. This is the Ikea standard Ikea cup. What I'm gonna do with this particular cup, I usually try to clean some of my berries, blueberries, raspberries in this cup, and in order to do that, I basically put some of those here, rinse them with water, and like I do this with my hands, right? So I try to drain the water by my fingers, and this is not very very easy, and sometimes some of those blueberries like kind of slip through and so on. So what I'm trying to do with this particular object that I have in mind, it's still morphing in my head, is basically having this strainer that you put on top of the cup, and basically you're going to use it as a standard strainer, but in this case it fits that particular cup. So again, with the use of CAD modeling and my 3D printer, that would be a super interesting and cool project. And I think let's start. I think the idea is super simple, and I think let's start digging. And the camera is at an angle because I need to work on the CAD modeling software as you see it right now. So let's start. Okay, so this first part, or this first section, what I'm gonna do is I'm gonna go ahead and design a mock-up of that cup. In order for the strainer to fit, it needs to fit the angle of the cup, the exact angle of the cup, especially around the lip area. And in order to do that, I need to kind of model quickly the cup itself, right? So I'm not gonna go into the details of designing the exact same cup because that would be boring, and we don't need that as well. So what I'm gonna do is I'm gonna take the inside diameter of that cup, which is 79.24, and the outer diameter, okay, which is 85.63, and I'm gonna do that exactly. The second portion is modeling the base. Again, this is not very important, but I'm gonna do it just for the fun of it. And that's 64.72. And last but not least, the thickness of the cup itself, which I think we could deduce from the previous parameters, but it would be roughly 3.4. And of course it changes across the contour, but it doesn't matter. It doesn't matter much. Again, on the base, it doesn't matter much. It might be a little bit thicker here. I think like maybe around 6, because it needs to be thicker on the base, but it doesn't matter much, as I said. And last but not least is the height. And this particular cup has a similar design between both. um, smaller cups and bigger cups, but I'm gonna use that one, the smaller one, which is the one that I usually use in this particular straining activity. So that's like 97.9. Let's round it to 98. It doesn't matter. And let's do that. I'm gonna apply a fillet here because this is how it is in reality. You see here, there is this small fillet around the edge. I hope it's visible. And again, if I'm seeking kind of perfection in the aesthetics and kind of in the similarity, I could still do these edges, but again, they are not needed for that particular product. So I'm gonna skip that part for now. However, again, for the fun of it, let's make it a little bit transparent, like in the actual product. It's a clear glass, so let's make it clear glass, and let's do that. Let's leave it this way. I think that's good enough. So usually when I do this, this is the design of the environment, right? So what and how you're gonna use this particular product in what context, specifically the surrounding object or the interacting object context. So right now, my plan is to add this strainer here, and in order for this to be easy to remove, I need to have some sort of a lip on the outside or kind of a shoulder for that particular strainer. So what I'm going to do now, I will start with the basic geometry of that strainer, and I'm going to use the revolve command for this, like I did with the cup. Okay, so for that particular section or for that particular part, this is the contour I'm thinking about, and let me say some words behind every of these decisions. So here I want to have this as close as possible to the contour of the glass itself. So I do not have, like, I have minimum gap in this particular section, and this right now is like around 0.3. I think that's enough because our nozzle is like roughly 0.4, and again this part will be 3D printed, so I will use that 0.4 as my guideline. I know this is not very accurate what I'm doing right now, but it's enough for the activity that we're trying to do. So I'm gonna just shoot for 0.4, and I'm gonna shoot for something around. Usually the way I do it when I'm not on camera is I try as much as possible to use this as my reference. And again, I use it as a for construction for the people familiar with SolidWorks out there, and this is enough. So in order to design it for 3D printing, this will be another interesting thing. If I'm designing this for injection molding, probably I would make it as thin as possible to make sure that I have no excessive material. But since I'm gonna probably print it upside down, this orange line, or this this orange line as the base, probably it will be a smart idea to keep this base as a solid base in order for me to print without supports. However, that being said, I could still dodge the bullet of having too much of the material the other way around from the strainer side, for which is this side, and I'm gonna do it this way. This, of course, does not need to be parallel in this case, but again, aesthetics, I feel I'm inclined to do it that way, and I'm gonna do this as a horizontal now. Okay, so I think with this we're good. What I've done basically is I made the base, which will be the part again facing the 3D printing bed. Is 2 millimeters thick. I made the this protrusion here 1.2 millimeters thick, and I made the height of that protrusion roughly 2.5. And again, despite the angle of 100 degrees here, I tried to make, and I left a little bit more of a clearance than the point 0.4. So this is more than a nozzle squirt right now. So that's good. I think that's okay. Actually, we could make it a little bit even 38.6 to make it a little bit yeah, narrower. I think that's it for the base revolve. I think I still need to do some work on it, but I think for the base revolve, I think we're good. I think with this we have a good base to start with. This is again the strainer like inverted, and again no holes yet, so we probably need to invest some time in this pattern as well. So what I'm gonna do right now is I'm gonna cut through that strainer some holes in order for the water to be able to flow, and I'm gonna look at it from the side of the cup. So basically, whenever we're doing this, I'm gonna always look from this side to make sure that I'm not bumping into that, and I have enough like kind of material in the game here. So let's do this. Okay, so what I've done here is basically I added some holes in. I try to make it as nice looking of a pattern. So basically, what I've done, I drew some concentric circles here, and I spaced the circles out in a certain structured way, or like with a certain consistent distance. I think aside from the one on the far end, I think we're consistent. And then as you go inwards, like yeah, it becomes consistent. So I think I follow the 15 millimeter diameter difference between circles, and after that we followed that pattern until the end. And I think here I just made it 10 millimeters because I was bumping into the wall of the yeah, lock-in lip that I have there. So with this, I added the circles. As you go inwards, the circles kind of follow similar to, I guess, a Fibonacci pattern. And I think with this, once I clicked done, I just went ahead and I repeated that pattern in the same way. So you see like kind of the spiral shape. Again, it doesn't have to be that particular pattern, but yeah, I just chose it to be, and I think it looks cool. The important thing that you just need to make sure of is two things. First, that the holes are not too big for the objects that you're going to try to strain fall through. And the second is you need to make sure that your nozzle diameter is taken into consideration. So for that particular one, it's 4 millimeters, so it's pretty big. But just to give you the idea of what I mentally done here, my nozzle diameter is 0.4, right? And you always need to consider that. So if my nozzle diameter is 0.4, at least for that particular nozzle I'm designing for, because there are other nozzles that are called like mosquito nozzles, which are in this case thinner, or like in profile. I think they go down to 0.1 or so. I'm not sure why it's angry at me, but let's just delete this for a second. But this is how big the 0.4 nozzle is. So if you decided to make that hole, for example, a 0.8, the nozzle will be very tightly rotating in a single spot, and then the hole will not come out in the way that you desire. So just be careful when you're designing something like this to make it as consistent as possible to that idea. And again, to avoid this, again, especially for 3D printing, since this is the series intention, to make sure that you consider that as one of the diameters in the circle is one of the things that you need to consider while designing. So that is basically it for the straining. I think we could make it a little bit nicer and maybe develop a different pattern, but for the sake of time, I think that would be not the focus for today. But let me just go ahead and unhide the cup, and this is how it's gonna look. It's gonna look like. It looks dry a little bit, so I'm gonna maybe add two handles, and in this case, I would use my own fingers as the guideline. So I think in this case, my thumb and the index finger are like roughly 17 millimeters wide. Again, there is a better way, of course, through anthropometric staples and stuff. But again, since I'm designing this for me, I think that's the benefit as well of having this particular thing done at the 3D printer, because you could design things based on your own anthropometrics. So what I'm gonna do here, I'm gonna add 2 ears to that cup strainer, and I'm gonna do that right now. Okay, so what I've done here, basically, I added these again 2 ears to the actual strainer, again based on my fingers width and anthropometrics, and I think that's it's coming together. And I added some fillets here to avoid kind of hurting the fingers and so on. One of the interesting things that you need to be careful of when you're printing this side to the bed, in this case, this fillet will need to progress in a certain gradual way. Otherwise, it will mess up the fillet and it will mess up the print as well. So you need to be careful, and you will notice that I omitted the fillet from this surface intentionally, because doing a fillet is as I said, is a gradual exercise, and I think here will not be. It will be not that much needed, and two, I think it might increase the complexity of the print itself. So let's leave it for the time being without fillets, and let's see. Last but not least, again, let me do a quick isolate. I added here another fillet, so when you're washing the thing, it doesn't hurt your fingers as well. I think it doesn't affect my contours that much, and let me see that. Or let me double check that. Do like a line. So this is basically it. Another thing that comes to mind right now is maybe I need to add another wall here. So basically it locks, but I prefer to keep it that simple. That way I might need, like, my engineering senses is telling me to make this a little bit taller, this particular dimension of 2.5. I want to go to like maybe 3 or something. Yeah, maybe even more, 3.2 2.5 or something. The reason, again, I feel it will look better this way. So that's maybe my gut feeling. Let's see if I'm right or wrong. And with this, I think that's it. Again, I'm really kind of inclined to make this as a character of I don't know, like not only kind of a dumb object like that, but maybe add a special kind of cartoon character on the face or something. But we could do that after the first iteration. Another thing that you need to learn while designing for 3D printing, like more or less, the first print will not come exactly as you desired, right? So again, there's always that learning curve. Iterations and so on is always a factor in design. So while designing something like this, again, I'm not telling you it will not work. I'm just saying the more you invest time, definitely there is a higher possibility and probability for it to work right first time. But don't get frustrated. That's all what I'm asking you to do. So it's not something that you nailed the first time, and it's absolutely normal to get it 80% right the first time, then 90% right the second time, then the third iteration is perfect. So give yourself a chance, and you're gonna see that as well while when we're doing something along this in other like videos and so on. You're gonna see that maybe this is too simple to get wrong, I would say, but other products and other kind of home prints that you'll need to have a little bit more patience. So I think with this, let me do a quick pre-flight check. Okay, what I'm trying to do here is to add a few more holes. I feel that this might not sync as fast as I want it to. So I'm thinking of adding another set of holes here, but let me try. Okay, I think that's better, much better now. Like I think there is a lesser chance of water being trapped right now while straining. I think that's cool, and let's save that. So okay, so with this, I think we're taking it right now to the 3D printer. This is the Prusa Slicer that I'm using for my Prusa MK3 S. And with this, I think we could go ahead and right now and slice it. What I'm gonna use here is a red PLA color, so I'm gonna use the draft quality. Again, standard Amazon Basics PLA. That's the one that I'm gonna use, and I'm gonna for such a product. I think it's super simple, super flat. No supports are needed, definitely. No brim needed, etc. And let me do a quick slice, and let's see how does it look like from the inside. Okay, it seems that the infill ratio does not affect much because it's basically like, yeah, you go from layer thickness to layer thickness, and you do not need it doesn't affect much. Let me try a different infill ratio. In this case, I doubt it will make a difference, but let me see. Yeah, as expected, nothing changed because again, it's so very thin, which invites the question, because this is something you're always gonna do, right? You're gonna take the product to your slicer, and then you're gonna see how does it behave with the layers and everything. So look here, the fillet that I was discussing a few minutes ago, it doesn't translate really to except to these layers, right? So if you're gonna take from the first layer, this is one layer, then the second layer goes a little bit bigger, then a little bit bigger, then a little bit bigger, then I think then now smaller, 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 and then you reach your roof, or the red surface here is your roof. And you see here from this squirting squirted lines, these are basically your nozzle, right? Or the nozzle nozzle contour and the nozzle thickness. I think that I'm very happy with the overall result. I'm just wondering whether it would be better to print at a thicker thickness, and maybe thicker wall as well here. But again, like with the iteration spirit that we're just talking, this is 52 minutes of print time. I'm gonna do this as a print number one, and with this, I will start printing. So I'm gonna export it now to my SD card, and I'm gonna print it, and we're gonna connect after this for a kind of a summary or what I've done after a few iterations or so. Thank you so much, and talk soon. And now that the print is over, we're back, and this is basically our nice cup strainer. So you could see that it printed very well. I'm very happy with the quality. I think this is a very decent, good first iteration. Don't get used to that, by the way, because sometimes it's not as easy and not as successful. So you see the PLA, the Amazon PLA red is the filament of choice, and you see the quality of the print is very nice and it's very smooth. And let's do a fit test right now on the cup. So this is our, again, the same Ikea glass that we've been using in the design, and voila, it works. So as you can see, and I'm happy. Oh, that's so funny. My mouth looks morphed in the glass. So you could see here that it fits, and this is basically what I mentioned about having these two holders on the side. So when you're draining your fruits or whatever you're cleaning in this cup, you could basically hold from, and it's basically very easy to use, and it fits very snugly with a slight clearance. I think we decided on a 0.4 on a radius, so this is roughly a 0.8 on the diameter, which is exactly nice and I would say enough for such an application. It will not lead to any leaks. I would say let's go and test it now and see how it works in real life. Okay, now that we're back, I think you've seen yourself that it works well, and I think it works in the way it is intended, I guess. And I like the fact that it's again very easy to print and super flat of a design. It's very simplistic, very minimalistic, and I like the human factors. Again, using it, I would maybe make the ear a little bit bigger here and here, just to make sure that it covers a little bit more of an anthropometric group, a bigger anthropometric group. So I don't know, like if somebody with bigger fingers or so will be comfortable using it. I think other than that, maybe I would design different patterns for the actual draining holes, but I think all of this is just like aesthetics at this point. So again, feel free to download the STL for this one and try it yourself at home. I'm gonna leave in the comments a Thingiverse link, so you could download it and check it out for yourself. And until we talk again, take care, and this will be our kind of starting episode in the Design for 3D Printing series I'm planning to kick off with this video. And thank you so much, and see you guys soon. Bye.